The next set of problems that we're going to look at are basically going to be working in reverse order of the ones that we just did. So this time, instead of being given a z-score and being asked to find the area, this time we're going to be given an area and asked to find the z-score. So we're working backwards. When we're doing that, instead of using the normal CDF option like we did before, we're going to use a different option called inverse norm. And so I'll show you that as we do these next three examples. So the first example, we're asked to find the z-score. So we know that we're looking for a z-score. This is a z-axis. We want the z-score that has area 0.10 to its left. Normally we start off labeling this standard normal curve at a mean of 0 and standard deviation of 1. And so we would label these with 1, 2, 3, -1, -2, -3. I don't necessarily suggest that in cases where you're working backwards because we don't exactly know where to place along the z-axis the z-score that has area 0.1 to its left. So we can get close. What we do know is, for example, if I was right here at 0, so if I was right at 0, the area to the left of a z-score of 0 would be 50%, right? Because we know the curve is symmetric about 0. So 50% is 0.5. So what we do know is if the area to its left is only 10%, right, 0.1, we know it's kind of down here somewhere, right, where 10% of the area is to its left. So I'm just going to kind of approximate where that would be. And here is what we know. And this guy is what we're looking for, right? What is the z-score that has area 0.10 to its left? Okay, and so in order to do this, we actually, we're still going to go to second distribution on the calculator. So second distribution. But this time, instead of choosing normal CDF, which we did when we had a z-score and wanted an area, this time we have an area and we want a z-score. We're going to choose option 3 that says invnorm for inverse normal. And hit enter. And it asks us for the area. One thing we have to make sure we are very careful about is in the calculator, when we use inverse normal, the area that we type in always has to be the area to the left of the value we're looking for. Okay, in this problem, it's already set up that way, but that's not always the case. When we're entering into the calculator, we always have to enter the area to the left of the z-score we're trying to find. So in this particular example, the first example, the area to the left of our z-score is supposed to be 0.10. So under area, we're going to type 0.10. This is a standard normal distribution, so the mean is 0, the standard deviation is 1. And we're going to hit enter, and we get z is -1.28155. And again, I said we normally round z-scores to 2 decimal places, and we place those z-scores along the axis, not up into the top where the areas go. So this is -1.28 if we round to 2 decimal places. Okay, moving on to our second example. This one we have some new notation that we need to get comfortable with. This is called z sub alpha notation. And the alpha down here always stands for the area to the right of whatever this z value is. So this is just asking us to find a z-score that has area 0.35 to its right. Okay, it's just a shorthand way of asking that question. So let's write that out here. We want to find the z-score with area 0.35 to its right. So this notation, when we have z with a subscript number down there to the right, that means that that number to the right of z is the area to the right. So the way I remember it is we write it to the right, and it literally is referring to the area to the right. So this is a z-axis. And again, we want the z-score that has area 0.35, so 35% of the area under this curve, to its right. So again, if I was right here at 0, 50% of the area would be to its right. Well, I don't want that much. I only want 35%, so I gotta scoot over a little bit, right? So kind of somewhere over here where I want this area to the right of that z-score to be 0.35. So we're writing that as z sub 0.35 equals, okay? Remember we said the way we have to enter this into the calculator is always we need to enter it as the area to the left. So the quick way to work around this is that if the area to the right of a value is 0.35, we know the total area under any distribution curve is 1. And so the area to the left would just be 1 minus the area to the right. So 1 minus 0.35 gives us 0.65. So when we go to the calculator and we choose inverse norm, we're going to go second distribution. We're choosing inverse norm. And for area, we're going to type in 0.65, right? We want the z-score that has area 0.35 to its right. That means it has area 0.65 to its left. And we always have to enter in the calculator the left area. So 0.65, mu is still 0. Sigma is still 1, so we had 0.6501, and that tells us is 0.385324, and we're going to round that to 2 decimal places, which would be 0.39. So you can tell I'm in a little bit of the wrong spot, right? It should be a little closer to 0, and I have it a little closer to 1. But somewhere right here around a z-score of 0.39 is where I would have 35% of the area to the right. And then the last example says to find the 2 z-scores that divide our standard normal curve into a middle area of 0.95 and 2 equal outer areas. Okay, so this is a z axis. Our mean is 0. And I hope that you remember from the empirical rule, which was that 68, 95, 99.7 rule, that's going to happen right around 2 standard deviations, right? Right around 2 standard deviations is where we get 95% or 0.95 of the middle area. To be precise here, that rule is not exactly 68, 95, 99.74. It's really about 68, 95.44 and 99.74. So to get right at 95%, we're going to be close to 2 and -2, but not quite right there. So basically, we know we're going to have some z-score down there and some z-score up here that divide this curve into a middle area of 0.95. And what we are looking for is what are those z-scores. Okay, and it says the middle area needed to be 0.95 and then 2 equal outer areas. One thing you can tell, again, because the curve is symmetric, and we're trying to find a middle area, that means the area in each of these tails is going to be equal. We know 95% of the area is in the middle. That means there's still another 5% left over, and we need to split that 5% up into 2.5%. So the area is 0.95 in the middle and 0.025 in each tail. So all we did was we found the area that was left over, and then we divided that area by 2 to get the 2 tails. All right, so because we know that these z values are going to be the same, just with opposite sign, we really only need to find one of them. This one's probably going to be the easiest because we have a direct number of what is the value of the area to the left of that z-score. So again, we're going to use inverse norm because we know an area, we are looking for a z-score. And so inverse norm, our area to the left is 0.025. So let's see, area. Our mean is 0. Our standard deviation is 1. And we get for that z-score, and remember we are working down here, we get -1.96 if we round to 2 decimal places, which tells us right away that this one would be positive 1.96. Okay, if we wanted to double check, just to be sure, the one up here has area 0.95 plus 0.025 to its left, right? So that's 0.975. And you can tell you get that positive z value of a 1.96, again, if we round to 2 decimal places. Okay, so in summary, when you are given an area and looking for a z-score, you're using inverse norm. When you are given a z-score and looking for an area, that's when you do what we did before, which is normal CDF.